We now have the summary statistics, the mean, the median, and between the maximum, the range of these values. And it was seen that the GDP, there was a kind of a shift, an increase from the lowest figure, the minimum, less than the median, which shows that a quarter of the is in GDP. Then in the inflation, we have the inflation actually was rising because I don't know. Inflation actually was rising because I don't know. It is predicting data depends on historical data, the past. But in Nigeria, data, the past. But in Nigeria, we a tsunami such that for the exchange rate, early 70s, a dollar was exchanging to 80 naira. But this is an anomaly. It didn't work like we say that we can predict the future from historical data. But the Nigerian way was the other way around. Don't know because of corruption, don't know because of the interventions we done. Who are beneficiaries of these interventions, maybe family members of those who are implementing these policies. Of monetary policies, we know it's principally done by the central bank. And because of the currency volatility, we don't know, and the implementation will not be as it is proposed to be, which will talk about the expectation, the law of expectation. And the new Keynesian model, you talk about sticky price and wages, you talk about these variables do not co-integrate. So in order to do the GDP and that of interest rate, it shows that using the root mean square error had a lower root mean square error, which shows that the regression tree outperformed the neural network. So in all, let me just conclude because there's no time. If we look back to retro policy intervention, in a way that the outcome will be of a betterment to society. So it is therefore, because of the absence of this, the virtual is not on site, I have to conclude that we as policymakers in all ramifications should test our data using the trained data in machine learning and also do the testing. And if they do the testing, and if the difference of this estimate, the one that has a closer estimate, should be adopted in making predictions. Thank you.
We are not leaving you yet, please. You just let's clap for him because we had the constraint of money. Because we had the constraint of not being able to stream the session. So please. Hello. Okay. You mentioned GDP. You mentioned machine learning. You mentioned root tree, penalty. So please, we have, at least while he was saying
integration.
We could have picked one or two things that will form an where you an interest. My own area of interest may not be exactly your own area of interest in his talk. So you can ask a question. He's here to answer us. He's from the CBN.
No, I'm not from CBN. Yes.
The guy is from CBN, so
World Bank per se.
Dependable.
World Bank.
no, sir. Wait, no. If you have a question or a comment or observation, please raise up yourself and acknowledge you, sir. We'll take them in order, one after the other. That's one. Who else?
Oh, tell me,
That is
ask
two. Wait,
the
no,
model
that is
now.
two.
Let
Who
me.
else? More than three. Yes, we have three persons so far. Okay. Ajibade, you are not saying anything. Sir, you are not saying anything.
You have a technical problem.
Okay. 4. Okay. 4. 5. 6.
It's okay
Please,
now.
if somebody say what you want to say before, just chicken out, no problem. Hello? If somebody has a question or made an observation you want to make before, just chicken out. So let's start. You know that one, number 1. Good afternoon.
My name is almost Peter Kazeem. Okay. Sir, the model is not displayed, so there is no need to scrutinize. If the model is displayed, then we can now see something. Thank you.
I think the okay.
Noted.
Okay, noted.
Noted.
Let me write that down.
Okay.
Even though we have not seen, the data clearly on the screen, the statistics is actually, to be frank, is numeric. So definitely, when you see the numbers here, numeric, it will give you the clear evidence of some, in terms of prediction, and also some aspect of decision making. So definitely, I hope. Did you get me?
This is the first, sir.
Good afternoon.
Good afternoon.
I don't know concerns my name. Ken Poliborisino lecturer. I heard you mention about corruption. I was expecting.
No, the corruption is that
Let's
leave corruption.
let me draw your attention.
It's endemic.
Most of these data we use for analysis. Sometimes we should add socio-economic data to it and deal less of more economic data so that we can see where socio-economic variables affect the system.
No.
Sometimes. So I was thinking you would
Okay,
do
that is recommended for future research.
Thank you very much.
Okay, number 5.
That is number 5.
That number 6. No more.
Rosa.
The only comment I have is that the way they discuss about this machine learning as if it is a new thing. It's not a new thing, it's statistics.
Yes.
Yes, statistics.
Yesterday, the man was talking about clustering.
Yes.
Clustering not part of
The statistics.
multivariate analysis.
Yes.
So they should not put a new name to something that is existing. All they are doing is statistics,
Exactly.
but they have stamped it machine learning. The only thing they have added is computer.
Yes.
That is all. Every other thing is statistics.
Yes.
Very correct.
Yes.
Rosa,
Yes.
tell us.
Clustering.
Well, the observation, once you start appreciating the history of statistics, you know that it started at elementary grade, and what knowledge does is to keep expanding.
Yes.
Keeps expanding until such. In fact, it's ad infinitum. Like what is I supervised a student, a master's student on neural network.
Okay.
And I came to learn that is it has an advantage over ordinary least squares, and
yes.
he had to compare the two. You understand? So the knowledge keeps expanding, but it shouldn't, as it were,
Go back.
neglect where it came from.
Yes.
And that is why the history of some of these subjects are very important.
That's correct.
You didn't have.
Please, sorry, I want to.
Okay, all
in
right.
addendum,
But we don't have.
University. Please, Prof, I want to plead because the way the data science, if you look at the academic, the CCMAs, they put data science
That's
into the
statistics.
computing, and if you look at it,
It's
All these
statistics.
things from statistics.
They are
So
statistics.
please, Prof, you need to work back to
Statistics.
Let me respond.
Thank you very much, sir.
Yeah, it was something that, see, the Nigerian environment is different. The whole thing was pure data science.
Yes.
And that was the argument we were making. I happened to be part of the processes for fighting. You find out that some people were playing the politics at the new level.
Yes.
Otherwise, outside here, outside this our country, we always see statistics and data science. All part of the problem we have is environmental. That is the academic politics around our place. Because the argument was with the news that time. But because of people have that advantage over others. Remember, computer science was pulled out from science and made to be a faculty of its own. And now it goes by the faculty of
Computing.
And it was good that universities will start debating on it, whether, universities is supposed to determine whether to create a faculty or not. But it came from there, it was given as a directive. And within that framework, they now said cyber security, data science, and all this should be so, but the argument is 3 months. Because we are still bringing in the experiences of others outside this country.
I think it will work now.
So we
It's not for speakers, it's for people who watching online.
No, this one will work
our
now. This one.
environment is not
Huh?
the politics content of it. It's not very fortunate.
Thank you very much.
Who said that? I don't know. I have my own take. Is there any other contribution? Any other contribution? Let me please say something. It's fortunate and unfortunate we have the word you used, and there are some acronyms that we also saw in your abstract, like VAR. Now, you said in your conclusion that the regression tree outperformed the neural network. Regression tree outperformed neural network. Is it not right what you said? Yes. Okay. You now said you used the rule, square, mean, error in doing that assessment. You use what?
What I use,
Yes.
root mean square,
Yeah.
is to do the counterfactual analysis. The actual estimate of the GDP, the estimate
Take it close to your mouth.
of the estimate vis-a-vis the estimate for regression tree and that of neural networks, that the root mean square error was lower in regression tree than in neural network. And the one that has the lowest distance is most efficient. And that is why it had.
Okay, there are things I want to draw your attention to in basic research and on this work particularly. Now, when you are making a comparative study of methods like this in contemporary areas like machine learning, there are some literatures you look at and the efficiency of this method compared over time. Now, this p-value was less than so.
Less than 0.05.
Does that make that is a condition for such a data set to be stationary?
Non-stationary. The null hypothesis is that it is non-stationary. Then if it is less, the p-value is less than the normal level of significance of 0.05, you reject the null hypothesis and accept the alternative.
Okay, so good. Take note of all this.
Stationarity.
Hold on, sir. You take note of that. We hope that the other presenter and our presentation will see exactly what we need to see. Thank you very much. Is there another question? Thank you very much. Thank you very much. Thank you. So we'll take up on next. Up on is a joint paper. Opening. As his name, please come forward. Yes. Thank you. Please. Connect it for you, please.
not everybody is audible enough.
All right.
How do we use this?
So I know you have presented.
Please, go ahead.
All right. Good afternoon, my professors and my distinguished colleagues. I'm Dr. Opone Festus from Southern Delta University, Uzoro, Delta State. I'm here to present our work that is titled Statistical Analysis of Life Expectancy Data using a new parametric model. Searching through the literature, one could observe that life expectancy data has been widely applied or analyzed using a non-parametric model. And in this work, we want to introduce a new parametric model, which is actually a probability model used in analyzing life expectancy data. We consider the life expectancy data of Nigeria from 1960 to 2022. Like we all as statisticians, life expectancy is a demographic indicator that estimates the average number of years that an individual is expected to live in a given population based on the mortality rates that surrounds or that is associated within that environment. Now we have a handful of non-parametric models such as the proportional hazard model, the Kaplan-Meier model, we have life table, we have also the Gaussian process regression model. And we could see, next slide please, some of the literature that has the non-parametric model are given in the slide. And also there is also a handful of parametric model, time series based model that have been also used to model life expectancy. We see that in the work of Asheri et al. In 2021, Beeman 2023, Awarefe and Equator in 2023, and Wang et al. In 2024. Like I said, we are proposing a parametric model that is probability based, and our interest is on the inverse exponential distribution. The inverse exponential distribution is actually one of the pioneering generalized exponential distribution that has been developed in 1982, and we see the CDF, the probability density function, and the cumulative distribution function of this model given in equation 1 and 2. Go to the next slide, please. Now, model selection techniques that has to do with the AIC, the archaic information criteria, and the Kolmogorov-Smirnov test statistics, the Agdaxin-Darling test, and the Kramer-Von Mises test with their respective p-values. And we see that from the data, from our results, that from the AIC, our model has the least AIC value, suggesting that it is well suited for modeling the life expectancy data for the male. And we also see from the KS value that our model, the proposed model, has the least value with the highest p-value. Same thing with the Kramer-Von Mises test and Agdaxin-Darling test. Please, the next slide. Our next table has to do with the result for the female life expectancy data. Same result we see from the table that our proposed model, which is the weighted harmonic inverse exponential distribution, has the least value in terms of the AIC, KX, Cramer-Von-Mises, and Anderson-Darling tests. Okay. In summary, we have proposed a parametric model to analyze life expectancy data of Nigerian ranging from 1960 to 2022. Thank you for listening.
You have references.
Yes, these are the references.
Thank you very much. Please, our comments and observations, please. Stand.
Okay.
Our comments and observations. So if you have comments, you have observations, you raise up your hand. I'll pick numbers, so we don't make it random. So who is number 1? Okay, number 1, number 2. Who is number 3? Number 3, number 4, number Ferre, number 5, 6. Yes. Do we start with this or 6? Okay, so let's start with this, sir.
My name is
7. Okay.
Dr. Cison Osifo Ojogun, the DG National Population Commission. I take interest in issues around life expectancy at birth. Well, beautiful work, no doubt. I want to really know whether we have tried to look at the age and sex structure in this, and whether you've tried to look at other data to see the relationship in terms of outcome. Thank you so much, sir.
Okay, number 2. Is that a question? You say whether you put age and sex into consideration in the data analysis for this type of life expectancy.
We have already done sex issues. They do consider age along the line because the risk of dying differs from age group to another age group. And after considering the outcome, I know it's very close to what is being done using life table and the rest of them. That's why I'm asking, did you really consider other parametric methods, whether they are closely related? And if there's a difference, what could have contributed to the gap? Before concluding that the parametric method is the one you are proposing, something of that nature.
Okay, want to respond? Okay, number 2. Maybe you can talk about, we know you have an audio voice. Rafael, please.
Okay, I think, can I take this?
Okay, you can respond. No, you can respond. Hold on. You can respond to this one so far, please. Respond.
All right. From the first question that was given, that was asked. Now, in lifetime data analysis, our interest is to model a data and see which distribution that the particular data for which distribution it follows, right? In probability distribution, our interest is to get a data set, to develop a model that is well suited for any kind of data. We already know that if you want to do any data analysis, first of all, you do more like an exploratory data analysis to show you behavior of the data. So that is our key interest. Every data follows a distribution. Now, for this life expectancy data, which of this distribution does it follow? That is what we do in probability theory. And so, the data that was we used is already an established data from World Bank that is showing the life expectancy of male and female citizens of Nigeria from that year 1960 to 2022. So our interest is to
Please, just a bit. Okay, right.
okay.
Okay.
Yes. Of course, but for the sake of this conference, we can explore all kind of data sets, and that is why we limited it to life expectancy data. Of course, it will work well for other data.
It's okay. We'll continue with our question. Hold on, please. Let's calm down, small. We have hello. We have Madam in our midst. Hello. Please, sir. We have Madam in our midst. He has an important information to pass to our female members. Please listen to her briefly.
Good afternoon, great statisticians. We have what we call female in statistics in Cison corner. I don't know how many of us female here are registered members of female in Cison. Please, we encourage every one of us. You find out that God are the days when like this field is for males. It's now for you and I as a female. And you find out that we do very well. Given our designed by God, when we go into data with this thing of nurturing a baby, carrying a baby, nurturing, you see we do better than the males. Am I not speaking the truth? God bless us. Thank you so much. So we want to encourage women, even from the secondary school level, to come and see what we're seeing. You know, there are quite a number of scholarship opportunities for women in STEM, in statistics. So we don't want to be left behind. So Cison wisdom has created a corner for women in Cison. Please, let's come along. Please, I'm passing the paper around. You go, all the women, your affiliation, your phone number, whether you're a registered member or not, please you indicate. Thank you so much. God bless us. You're welcome.
All right, let me clarify something.
Please, let's be quick on our questions. We have line up of presenters. Please, yes.
Yes.
We have various characteristics. Each parameter describes in this I can't see it here, but very clear. How many parameters has this model, and what type of characteristics those parameters describes? Thank you.
Okay, hold on. You hear what he said?
Yes.
You hear what he said?
Yes, yes.
Okay, next. We can hear you, sir. You can
Okay.
speak. We can hear you.
Yeah. From the presentation, he proposed a newer model than the existing one. But like he said, we don't know what he's actually targeting to improve on in the new model. He didn't just oppose the old model and the new one. And then he applied it to a very sensitive data, which is life expectancy in demography. Any data that has to do with human being, with life, they follow a specific pattern. So if you propose this model, have you tried to do a 3D pattern generation of graphics to see the pattern of this your new model, whether it's applicable to human data? That's my question.
Hello, let me quickly say this. Shift to your corner, don't worry. In the course of your work, I want to conclude with my comments so that we can go further quickly. In the course of your work, you use the word non-parametric model. You use the word linear model. You use the word life table. And but I didn't see where, when you were comparing your methods, which is a parametric method, you compare it with any of the non-parametric method. Because there are very many non-parametric methods in literature that solves problems like this. I was happy that the method you are proposing, in your question 3.1, 3.2, 3.3, where you saw the deviation where the difference between the method where the inverse exponential, where you were taking a difference to your own approach. Good. But we would have preferred you also look at it from God's point of view. The first presenter asked you other indices like age. Me, I wanted to have added even environment because we have they call it population determinants. That means that determine population pattern. Like for example now, you won't expect those in the arid region to have the same life expectancy for those with a temperate or a tropical region. Those in the desert, the arid region, they have difficulty in fitting to life. So their life expectancy will be affected by those factors, population determinants. So one would expect that the notion that the average life expectancy is 50-something, 50-something years. But most of us are more than 50-something years. We are still alive. Hello? We are still alive. So that means that, hold on, that means there are some assumptions that you have taken that may not have really suited generally. That's why people like Professor Ogboma also look at issues for non-parametric approach, because he feel that nothing in real life is static, depending on how you view it. People in the non-parametric statistics world, they believe that there should be little or no assumption about any model or formula. They call it distribution free. They call it that data itself speaks for itself. Having collected data for such a long time, let the data attribute be what determines the statistical inference from those data sets, not a model that traditionally have been put in place that have its own structural effects. I do not consider other variations. Life itself is not a straight line situation. We wanted to start by 9, so we know where we started. We wanted to take a tea break, you know where we took. So things are not necessarily like that. So the informations or the comments from everyone is that, including me in support, is that while this proposition is very robust and seems good, because I look at all the properties you have to consider for a model to be fit, including the Kaplan-Meier method. It's a non-parametric method. It's a non-parametric. And so if you were looking at a non-parametric testing criteria for a parametric method, means that there's an idea that thing has to be considered. One of my fourth PhD students did a work on this, something like this. So we have to search ourselves, Are we answer all the questions we need to answer for a model to be determined to be fit, to be proposed and sufficient? That was when it dawned on me that these things has to be looked at differently. My first PhD student is in one of the sessions around. we have looked carefully on this type of situation. So, or a part of this work before, even if you have. So this area is unique, and everyone is interested in how you develop a new method. From where is the deviation? Why the deviation? What have you achieved? What did you not achieve? What could you not achieve in terms of time, in terms of computational cost? Then, if somebody doing this thing, what will it go to achieve? You use a software. Which software did you use to achieve this? So that a beginner, someone that may be interested, doesn't want to spend energy, doesn't want to use the old method, can employ. These things has to be put into consideration. Thank you. Please take note of all this, and thank you. Take note of all this. Yes. Take note of all this. Thank you. It's a joint paper. Let's give you a round of applause. It's a joint paper. Come and document it now before we take the third one. Please document quickly so I will take the third one. So the third one we are taking is Mr. Azaya Kwan. Which are we taking next? Please. If you have your work, document them. No, is the paper with him there. Call the name of the next person there to present.
Good afternoon, everybody.
Wait, before you come in, is there every paper is from one university? Why not one from this university collaborating with another one in another university? When do we start collaborating? Financial application. You don't have to make friends. All right, go ahead. Madam, go ahead. Please.
Everybody. My name is Adigun
Where's Adam?
I have failed in statistics. My coefficient to be precise.
Maybe the other one's number 4, Abi?
Yes, number 4. But number 3. Number 2 is not
around.
Registered yet.
Okay. Thank you.
Unemployment and its role. Unemployment and its role in crime rates in Nigeria, an empirical investigation using AHDF augmented fuller lag. We are like 4 people on this thing. We are talking about the unemployment. As we all know that in this country where we are, the major problem of people is unemployment, which leads to crime, and the rate of the crime is alarming every day. The study investigated the relationship between unemployment and crime rates in Nigeria for a period of 2012 to 2022. We have the descriptive statistics, the chart is there, which we will see later. And many literature were reviewed which support that unemployment is a trigger to crime rates in Nigeria. And what are the government at all levels doing to prevent the unemployment? If they can provide the white collar job, there should be something to be done to ease the terms of unemployment. Please, the next slide. Okay, a popular adage says that an idle work is a devil workshop. If you don't work, if you don't have anything to do, you will definitely think of how to survive, either by stealing or do what is not right. Again, we have from the NBS, the National Bureau of Statistics, poverty gap indicates the depth of poverty in particular household, and Gini index represents the statistical measure of expenditure distribution in the country. That is NBS 2019. So I'm trying to open it. I can't see clearly there. I'm trying to open it on my phone. Next slide, please. Next slide, please. The frequency and distribution of these crime rates have instilled fear into minds of all of us here, that sometimes even at home, you shall not feel safe. They can just come into your home at any time. And again, it is most appealing that many of these crimes like armed robbery, kidnapping, for tension, Boko Haram, insurgency, and X-Men attract happen in broad daylight. As I've earlier said, the perspective expect without being apprehended, they will just go free of charge. Even if they are being taken, what is being done after they might have been apprehended? Nothing. You will just hear the news, but after a few days, few weeks, nothing again. Let's see what we are about people that are EFCC. What is the outcome of all what we'll be hearing? Nothing. The Lord will save us. Next slide. This research work reviewed relevant literature on unemployment and crime rates, among which we have Accra, it's all 2013, and so many literature were reviewed that support that unemployment is an element that trigger crime rates in Nigeria. Next one, please, to save our time. The study made use of secondary data sourced from the World Bank Indicator and Nigeria Bureau of Statistics from the year 2012 to 2022. The study used augmented equivalent text to show the trend of constant, that is the stationarity, over time. Maybe it's the same over time. The process, the crime rate, and maybe they are the same process over time. And the augmented distributed lag model was adopted as an estimating technique to analyze the data, and from the data we have the results. The next slide, please. We have this, we have change in time, which will give us the constant into the file of y lag 1 plus the error term. And we have that the test statistics will give us the sigma into the standard error of that sigma. The next one, please. The next slide, please. We have the result from figure 1. Please, let's show the figure 1 before we come back here. Let's see the chart. You can see the rate of unemployment. We can see that in 2015, if I could see properly, it's declined. Maybe there's some policy that was in place to reduce the trend of unemployment. And again, when something starts, it moves up again. That shows the level of our insecurity. We can see it. So let's please, before the previous one now. Figure 1 explains the descriptive pattern of how unemployment trigger crime rates in Nigeria. The number of recorded crimes been increased in recent years, with significant increase noticed between 2017 to 2022, while that of unemployment rate decline, as I've said, maybe due to some palliative measure by the government at different level, maybe the local level, state level, or international level, federal level. And before going on constant increase from 2017 to 2022, figure 2 and 3, as we will see, shows that after defining, we have the difference you see here, it comes up, and we have it in 2022. Again, for the crime, for the crime and for the unemployment, as I've explained it earlier on. Please, the next one. Now, sorry, we can't view this properly. We have the descriptive statistics of the mean, the average number of crime rates in the year from the year 2012 to 2022. This one is not visible enough. We have the times, we have the mean, we have the median, and we have the standard deviation, we have the skewness to the right and to the left. The next one, please. This table displays the distinctive characteristics of the time of the crime figure and unemployment rate between that year. And we could see here that the correlation analysis of crime rates and unemployment rate in Nigeria, the crime rate to crime rate will give us one. As great statistician, that show is they are one unity. And for that one, we have, for unemployment and crime rate, we have a very strong relationship between the two of them, which give us 0.7, which give us a perfect relationship between the two. The positive correlation figure 0.7 suggests a strong positive relationship between unemployment and the recorded crime figure. This indicates that an increase in unemployment will also give us what? Double increase in crime rate. As we can see, the significant level of 0.16, which is less than our usual level of significance, 0.05. So that indicates that we have to reject the non-hypothesis. We say that crime and unemployment are not the same, but it's saying that we have to accept that they are what? So they are the same thing. Again, here we start for the stationarity. Differencing, which involves subtracting the previous observation from the current observation. The first and second difference was performed on the crime series, while just the first differencing was performed on the unemployment series in order to make the series stationary. And from what we have here, I'm sorry, it's not visible. The level of significance is less than the critical level, which make it stationary over time. It has no unit truth. That means it's what? It's stationary over time, which indicates that unemployment will definitely trigger crime rates. The same thing is applicable to unemployment. The other one was on crime. Here we have minus 3.5, which is still within the significant level of minus 1.9. The hypothesis was rejected and conclude that the difference unemployment series has no unit truth, which means it is stationary over time. The next one. And we have the model. I'm sorry, all these things are not visible so that I can explain better. But with what we have here, the correct one is in the real work. Please, the next one. Let's go to the result. Okay, the previous ones. No, not this. There is one before all these ones. Here, there is no serial correlation to the specific log order in the residual, and there is serial correlation. Table 5 explains that since our F table, that is our F table, is of 0.5, which is greater than the common significant level, that shows that we accept the H0 and conclude that no evidence of serial correlation. This implies that there is no bias due to the high correlation in the prediction of crime rates. If government at all level did not do anything to unemployment issue in our country, there will be what? High rate of crime at every level. The Lord will help us. So we can see from all what I've been saying that we have the percentage of 0.7. The correlation is statistically significant with the p-value of 0.16, which is less than the conventional statistical threshold of 0.5. This significant relationship underscores the critical connection between the economic condition and social outcome, particularly in the context of unemployment and criminal activities. Our R-square gives us 0.8, which indicates 89% of the variability in crime figure could be explained by change in the unemployment rate. The findings suggest that where there is a strong relationship between unemployment and crime, unemployment is a strong predictor to crime rate. And at this level, we are all teachers in our various organizations. We should teach people to do something. They should not sit back and say, I don't have a work. You can do something no matter how small. By the time you start from that small, you graduate. But it will be disastrous if you didn't do anything. So thank you. From here, I would like to stop my preaching. God bless you. No, it's not here. It's in the real work.
Hello, before we take comments and hello, with all due respect, this is academics. It's not religious. If you are in religious class, this is academics. It's not religious class. Please, that is one. Number two, we would like to see the references. Some of the things that we need to make corrections in, we need to see all of them. Though the first presentation we had a lot of technical problem, we believe by now. You said a number of times, it's not clear, it's not correct here, it's not clear. Why don't you show us the one that is clear? Why don't give us the very good one that we need to have seen? Is it a projector problem or what?
Yes, projector problem.
Your choice of words should be such that will reflect that it's not from your own end, it's from the projector. Okay, please comment. Thank you. Let's give her a round of applause. The first female. All right, please comment. We'll take numbers. Okay, sir. 1, Prof 2, 3, 4. I think 4 should be enough now. All right, sir.
Well, let me thank you for that good presentation. Thank you, sir. So, and when you started,
You can hear. You can.
When she started, I asked myself, what is crime? Yes, and we are looking at the correlations. Is it financial crime? Is it property crime? And other types of crime. And I just jokingly told my friends here, I said, is it in the number of crimes or in the volume of crime? Yes, if it is quantified financially, a man steals 20,000 naira. That's one crime. Then one man took 1 billion. That's still one crime. So is it in the quantity or the quality of crime? I think those kind of things, we need to define the type of crime we are talking about. Whether it is the harmful crime, property crime, robbery, and the rest of them. Thank you so very much.
Okay, Prof. No, you're listening.
Thank you very much, sir. Yeah, still on the same variable problem. You made use of ARDL, right? You didn't state the conditions to use ARDL. Can you hear me? Sorry. Oh, okay. I said she did not state the condition for use of ARDL. How many variables did you make use of? How many variables? 2. You did not indicate the one that is stationary at levels and the one that is stationary at after first difference. I heard you mention even second difference, which disagrees with ARDL. So how do you justify that? Again, I didn't see the short-run model and long-run model in our ARDL results. Thank you.
You may need to respond to this first. Please respond to this.
Okay, sir. Sir, I'm talking about crime at all level. Crimes are at all level. If you steal 1,000 and 20,000, crime is crime. Sir? Yes, number of crimes. So you are talking about, is it quantity or rates of crime?
Rate has to do with number.
Yes. But what I'm dealing with, the crime here is at all level, whether the number, the volume, crime. Once you know that you do what is not good. Sir? Yes, you go against the law. Yes.
So how did you get it?
It's from the Africa Development Bank. It's a secondary data, sir. So I'm talking about the condition for ARDL. Yes, you have to be stationary.
At what levels? The condition is that one must be at least one non-stationary.
Yes.
Then one stationary at first difference.
At first difference, yes. Yes.
I didn't notice it.
Maybe it's on the rework there, it's there, but maybe I didn't speak to it. Yes, sir. It's there.
Okay. Please, last number 3.
Good afternoon.
Sir.
The next person.
Okay.
Let me draw his attention.
Let me commend the speaker here. He has done a very critical work here. This is looking at prevailing issues. You are looking at unemployment, and at the same time you are looking at crime. And this is a very significant topic here. But my question, I wanted to talk about the ARDL because I did not see you reporting any result on short run and the long run. At the same time, I did not see you specifying why you use ARDL for this particular research, because I think there are conditions for it, though he has spoken about it. But my interest now is, since we are looking at unemployment and crime, the moment I become unemployed, is it that time I started thinking of crime, or there is a lag period before me going into crime?
There's a lag period, sir.
Okay.
It's there in the body of the work. There's a lag period. Once you don't have some things
It's all right. I just wanted to...
Yeah, there's a lag period before you can be thinking of how to survive.
Okay, thank you.
Hey, very good.
Okay. Thank you. I would like actually to apologize. Not every paper that I will comment. The first one actually it has a lot of comments, but the social scientists cannot say anything. Only the scientists. So the commentators actually has not say anything because they have to talk about model, then the parametric. So I will leave it here. Go to the comment of your paper. Definitely given the variables, crime rates and unemployment, definitely you have tried a lot in the sense that whereby you have correlated crime rates and unemployment. Definitely you have to show the statistical tools that you use, whether you use Spearman correlation or rank correlation. So definitely one should be showing on what? On your paper. Then another one, you want to actually, there is need to predict when we have so percentage in the crime, what should be the unemployment in the future? Or if there is unemployment future here, what should be the crime? So in that sense here, regulation analysis, you have to employ the regulation formula so that to be able to use to predict, other parameters. Then definitely here, for the first one here, he has tried in creating the model. So definitely the people, the professors, the doctors here, the lecturers, the staff and the statistician, they have to what? They have to say something. He has created. If there is no creation of model, or you can use the formula, how will you use to be able to design, to create a programming that you can use to run it in a computer? Thank you very much.
I didn't understand this question. He just make an observation. It's not question, it's just a comment.
Yes. Hello. Hello. He's making a comment that reiterating some of the observations that have been made. But one thing has to be said. You own the assets and the liability of the work you have presented. Even if it's a joint work, you should have presented it that holds the assets and liability. So key words as in informations that are key in your presentation has to be said. This to everybody. You don't assume that some of us know. Long run, short run, and so on and so forth. The first speaker made a very salient question. The information about rate of crime or crime. Rate of crime and crime. Somebody that steal 200 billion, one person, and 50 person steal 1 million. The rate of crime here is different from the quantity of the crime committed now. And you have said that, you use the word loosely, which we both observed, and said that when you said unemployment and crime, they are the same. It's not the same. In the terms of what you are doing, the correlation are the same. They correlated the same way. Don't that they are the same, choice of words. So I haven't said that, I think those things generally that we need to see or know when you are presenting your work, please let them be opened. Don't say because you don't have enough time. Those important information you don't give it, so you don't have to mislead others. So I wouldn't want to ask too many questions. You can present your work. Nobody will ask more than 1 or 2, or even at times they will just apply and you will go. Not like the way the Reverend Father used to preach. Nobody ask him any question. He will just go. Just the way judges used to go to court, they will make a judgment. Nobody will appeal. Whereas there are some judges, after their judgment, in the next day, and they get a certified copy of the judgment, it's appeal. When there are some, after the judgment has been made, both of them, all of them will go. Whether it's favorable, they don't appeal. Because they know the judgment was thoroughly examined. So please be guided. Let's clap for her again. So our next presentation. Please, if you have your work, you have not, Madam, update. So please, let's hold on while we wait for Mr. Edike Unandi to. Okay, sorry. Lord Matthew present his works. Thank you.
Okay. Good afternoon, my professional colleagues. Yes, I'm Dr. Matthew Chukuma Michael by name. And the work I'm presenting is a statistical method for the analysis of results from controlled comparative diagnostic screening tests and clinical trials for a condition in population. So in diagnostic screening tests, results are usually in dichotomous forms, either the presence or absence of a condition, or the recovery, whether the person has recovered or did not recover. And the major statistical techniques used for this analysis of this type of data are usually the student t-test, that's the t-test for significant differences, and then the normal, that's Z test. Then we also, when there are cases when the data will be better if it is in, hello, the next slide please. There are some cases where the data will be better if we present them in mutually exclusive forms that's more than dichotomous outcomes. So now the existing statistical method for analysis of this type of data is the chi-square. But these methods mentioned have their shortcomings. That's why we have the problem. Now the first problem there is that the classical methods require some normality of the population. That's the distribution has to be either normal, or there are some parametric assumptions on the distribution. Then the second one is that the classical chi-square test is not stable with sample size. That's this type of chi-test now for analysis of mutually exclusive outcomes. Then there is now the need, that is where the significance of this work will come, to develop a statistical model that is robust, as in that does not, is not sensitive to sample size, and it is stable with sample size, like I said, and it also has no, outliers do not have effect on them. So go to the next slide. So like that's the significance. You can jump here because I've mentioned it. Then the objective now is also part of what I've mentioned, is to develop a statistical model that is not sensitive to population size and is not affected by outliers. So the new method now, as I mentioned earlier, in the diagnosis screening test, is a researcher or a clinical scientist might have collected data on n observations. Now these n observations, I call them n dot dots, that's n subscript dot dots, of matched pairs. Some will be given a treatment, one, which is the control treatment. Another set will be given another treatment called the second treatment. So their mutually exclusive outcomes will be C, where C is greater than or equal to 2. So continue. Then this is a typical distribution of the data that will be obtained from the that's the analysis. You have n observations, that's n dot dot, that are arranged in an array, that's a table like this. Those on the columns were given with second treatment, that's treatment treatment 1, which is the control treatment, and those on the rows were given with the control treatment, which is the test treatment or the new treatment, which is treatment 2. The next slide, please. So to formulate the model, that's the new method, from that our table 1, we generated a cases, this CW subscript CA, all the cases where the results from treatment 1 are better, treatment 2 are better than the first, which is the control treatment. Now a summation through the rows and columns will give you an estimate of that's the number of cases where the treatment that's the result from treatment 1 is better than, treatment 2 is better than the control. Then the estimated frequency is equation 2. Then the corresponding sample proportion is in equation 3. Then the number of matched pairs in which treatment 2 are lower, this one they don't perform as well as the control treatment, is in equation 4. The sum over ij. For I, that's the row, it is from 1 to C minus 1. The technicality of the summation is obvious there. Then from the second one, you sum from J being equal to 2 to C. Now the condition is that L is less than J. That's equation 4. Then we still have the sample estimate for the proportion in equation 5. Then we now develop a difference, which is the gap between those that's the treatment where CA, that's the test is higher, and the distance between it and where the control is higher. So that is equation 6 there. It's just a subtraction that gave us that. Then the estimate, the sample estimate is given in equation 7 for the numbers, and the corresponding proportion is given in 8. Then the sample variance, for the proportions now, ordinarily from proportions in textbooks, you have variance for pi being equal to pi into 1 minus pi all over n. So following the same way, we got this equation 9, substituting equation 8 in the left hand side, this side, we got equation 9. So this the estimate for W now, the general gap is
n into pi, and when we evaluate it, it will give you pi plus minus pi minus, where pi plus is the proportion of those, that's the proportion of cases where the second test, the new test, is better than the first test, and pi minus is the proportion of cases where the first test, which is the control, is better than the new test. So the null hypothesis to be tested now is in equation 11. That's that the HO is that W is equal to CA minus C subscript W subscript A minus W subscript CO, which is where the new case is better minus where the old case is better. And the alternative hypothesis is that the proportional difference is not equal to 0. The next slide, please. Then the test statistics now, where is chi-square distributed when the sample size is significantly large, and the degree of freedom is C minus 1. Then the degree of freedom, I mean the significance level now, 1 minus alpha, is also stated in equation 13. Then the application of the method. We collected a random sample of 200 patients treated with 2 malaria drugs. The first case is the artemisinin-based combination therapy. That's the treatment 2. And then the second one is the sulfadozine pyrimethamine, that is T1, which is the control. And then it was used to treat those candidates. Don't worry, go ahead. Nnamdi University Teaching Hospital. So this is the outcome, that's the distribution of the outcome on the table. So these people treated with a T1, they have the upper case is improved, lower one is no change, then the worse. Then for those treated with a treatment 1, improve, no change, and then worse. So that's how it is distributed there. Go to the next slide. So we had to now apply the methods developed in our, that's the new method. And these are the values we got. For WCA, that's where T1, T2 is better than C1, is 35. Then the estimated proportion is 17.5%. Go. Then similarly, for the number that where T2 is lower than, that's treatment cases administered with T2 are lower than cases administered with T1, we have it as 67. While the proportion, that's the proportion, is 33.5, sorry, a percentage. Then from equation 6, we had the frequency, which is from what we have gotten in the 2 observations, that is the calculations then, minus 32, and then we still have that the corresponding sample for from table 7 and equation 7 and table 2 is pi, which is equal to minus 0.616. Then the sample variance is I've got it from equation 9 and table 2 using the chi-square. That's our the chi-square distributed variable that we developed is 0.007. Right. Then the null hypothesis HO now is of equation 11 is now tested with our method, and we had a chi-square value of 36.57. Now, and at 2 degrees of freedom, that's C minus 1, because we had 3 rows, 3 columns. So minus 1, 2 degrees of freedom, we had a statistical significance at 0.001%. That means 0.001, which is 1% level of significance at 9 point, the chi-square value is 9.210. Now leading to a rejection of the null hypothesis. So we started to test, the normal analysis of frequency that we use chi-square for, we use the traditional method so that we check the difference between our new method and the traditional chi-square method. So for the chi-square method, the calculated value is 16.279, which also shows that the test is significant. So the value now is that our own method, the new method now, would seem to be more powerful or efficient because the variance here is higher than that of the other test. That's the traditional test. So you can, my brother, go there. No, it's lower, sorry. That's efficiency, sorry, my dear. It's a slip of tongue. So the condition of cases administered T1, that's the new T2, the new drug, and the condition of cases administered with T1, on the average now, is not the same, which means that it depends on the treatment type. That the treatment type shows the group that will be recovering faster, or the number of persons that will recover faster. And from that is what I've said before now. Although the 2 statistical methods used here lead to essentially the same conclusion, the method which has a larger chi-square value, which is a lower frequency chi-square, is likely to be more efficient and hence powerful. So the new method now is an improvement over the existing chi-square test used alternatively to analyze sample data on test results from controlled comparative diagnosis screening test. Now these are the references. Thank you very much. God bless you. Yeah.
Okay, please. Hello. I've heard him talk about the presentation. I've seen his present. Please comment, observations. Let's take number. Okay, Prof's 1, 2, and 3. Remember, you are not asking questions. You are keeping observations to yourself. No. This is not sharing of family income. Say something. Family income can come from it. 3. Yes. Madam President, ask question now. I will ask him to tell you the title. It's a question. Yes, please. So 3. All right. That's our problem. So you go back to the formula equation.
The equation. The equation, the first equation there. Okay, but for the list, I think it's still going.
Everybody.
Females.
No, go back again. Go back. Just this. An introduction. Okay, something like that. Okay, we can use that. No, after that table. Yeah, how do you mention L? Is it L or I?
No, I use I. I is more common in usage, but I use L here.
Why did you jump? Why did you leave I and went to L?
Why I use L in place of I is that in the main work there are places where I use source script I for improved. So source script non-improved N. So in the main work, so that I won't be confusing them. That's why I use L.
Sorry, you know the genesis of IJ is because I comes before J.
Yes.
So but you have now jumped to L. Yes. Now is it J equal to, is it I or L there? Yes. J equal to, no, the second, okay, 1 to, where do, yes.
We have an array. Can you show me that slide? The way the summation is when the diagonal elements are where those, like in this case we have, please show me that table, second table.
Sorry.
That's all. Yes. So you see this case now, these are the levels of...
sorry.
Dedica.
So these are the levels that we call L, and these are the levels that we call J. Now, at this particular point, I and J are equal. Are you with me?
You're not using I again, or you said J.
The conventional
J. Why don't you come back to our I?
Okay, I will bring it to I. Let me use I.
Better. I rest my case, better. Yes, thank you.
So this I now.
No, don't worry again. I'm okay with that.
These are people that have used to L. We are saying let's use I instead of L. Because even me, that's what I use more generally.
Hold on.
So in this case,
I want to. Okay. Number 2.
A model that will not be prone to outlier. Robust that will not, outlier will not affect. But the illustration you use has not shown that outlier is there. Because one of the properties is that the frequency must be less than, if it's less than 5, it will not be prone to outlier. But all the one you have there. No, what me I'm saying is you should use the illustration where we have a value, a frequency less than 5. Let's see the way the result will appear. That's what I'm saying.
Hello, number 3. Please, let me to hand it to
Good afternoon. Yeah, I have to commend you for what you have done, but I'm really curious. Is there any recent research that has done what you have done now? Because most of your references, I don't see maybe 2022, 2024, 2025. Maybe after they've left this method, you are the one bringing it up. Oh, and secondly, I heard you talking about the T student distribution. Is it applicable? Have you used it here? You've not used it? You used the chi-square. So you are looking for the discrepancy between the expected frequency and the observed frequencies. Is that what the chi-square does? Your own is a different model. Okay. My expectation is when I'm looking at research like this one, which is noble, at least I would want to know why you are using the method you are using, and I want to know those researchers that have used the same thing and what their result says. You understand? Is it what you got that they are getting, or your own has deviated from that? And another question I have for you is the null hypothesis. What is your null hypothesis? Can you tell me what is your null hypothesis is in all the cases you've referred to? Okay, in my little knowledge of statistics, what I know about the null hypothesis is. Okay.
Okay, observation, please. I think he's presenting. It's not a question and answer session. So, any questions that you have, you will say it, somebody will record for him. Are you getting it? So that he will now go and look at those things. And if you cannot if you are not able to get those questions now, you can reach him through his email, so that it does not be like examination. So please let us his presentation of this thing. So all you just need to do, get somebody to be recording for you. You are not to be answering all the. Sorry, I'm Professor Edokpa, so that I introduce myself. Thank you.
All right, thank you. So we still have any other person that have a question or observation, please? If you are saying it, it's okay, but if you are writing it down and getting it across, it's still here. It's not going away today. Are you going away today? No, please, let's get that noted. But you must understand the comment of that last, the first one is very important. I have the same observation.
If possible, reach out to him. Let the
yes, because. Okay, it's good we also make some observation here so that we know where we are going. You want to respond?
Hold on. If people have observation, they should make. It's not reaching out to him. There are some observations that people need to share here. Yes. Are you with me? No, you have already said it.
Yes. So please, just as I said earlier, there are some critical observations that we must observe and say here. It's not everything that. Not at the beginning we said that it's not a fighting session. It's a place where you have constructive criticism with a view to improving the work. So please, that should be noted. Thank you. So he said you want to respond to mirage of information or what have you asked. So let's give opportunity to respond. Okay.
That's this man.
Are you done with your?
Yeah. Okay. So that I won't forget. Thank you very much.
I will first of all thank you again for being able to see the references. I was not even seeing it, so I should thank you for seeing, which means you had interest in what I was presenting, actually. So if you
if you see the work, we have references from 2022. The oldest reference there is 2000, I think 2006. After that, 2020, 2012, 2009, 16, 19, 19, then 22. So maybe the blooders of the screen. But one thing I want to answer again from what you asked, you are asking, what's that question again? The chi-square, yes. If there is an existing method, or why did I choose the chi-square? And I mentioned something on t-test, then your hypothesis too. You see, the t-test and the student t-test, and the student t-test and the normal test, they are doing the same thing. Just that the t-test is used where the sample size is very small. And now they are used to test least significant difference. Now in this case, they treat continuous variables, like your weight compared to another person's weight for some data, for data set. Now, we are looking at, and these things are done, you can see the outcome, dichotomous. Either the weight is higher or it is lower. You understand? But we are talking about a generalized case where we have mutually exclusive classes. Like, if it's an accident now, severe, more severe, you know, stuff like that. Then, the method that has been used in traditional statistics to sort this problem is the chi-square distribution for analysis of contingency table. And the aim of that, the use of that thing is for that particular test, is for test of association. That's whether there is association between two classification variables. You understand? Now, this work we have done invariably has tested for association. That's why I concluded by saying that the response of the patient is not dependent on the type of treatment, that it is dependent, because the null hypothesis that it's not, the null hypothesis is that it's not dependent on the type of treatment. So that even if somebody is being treated with ACT or with sulfadosine trimethrin, the healing rate is the same. That's the recovery rate. But now the test is saying no, which means that it is not, there is an association. So what the chi-square does is to notice the association. But if you look at the work critically, you will see that those treated with ACT, they have higher number of people who responded. So that's it. Thank you very much.
Dr. Martin, we know that if we give you time, I know why Dr. Waziri said she be writing this down. We will give you time, you will talk and talk and talk and talk, we'll know who live here. So I can see why Professor Waziri was correct. All right, please, we'll take one more presentation. When they call for the lunch break, we'll go there and come back. Please, which is the next step, Mr. Isaiah? The one that take the ticket, the one that take the ticket. Yeah. I'm not going to write a ticket for somebody I'm not taking. No, this is one that's coming. Sir, success.
You're really working.
It's working.
Okay. Good morning, ladies and gentlemen of statistics. The topic of discussion is symmetric and asymmetric dynamic conditional correlation, multivariate GAC modeling of micro-financial variables in Nigeria. Next slide, please. This slide is about 18 of them. It covers this outline: introduction and motivation, research objectives, methodology, finding and conclusion, and implications. In the introduction here, we all know it is not new to us that the center point of our Nigerian economy goes around oil prices, goes around exchange rates, exchange rates, stock prices, and inflation. And it is in lieu of this particular centered point of our economy that this study decides to come up, looking at other previous studies that is usually symmetrical. At this time, we decide to now include a symmetric approach of the GAC model. Next slide, please. The aim of this study is to employ symmetric and asymmetric dynamic conditional correlation multivariate GAC models to determine the nature and magnitude of volatility spillovers and time-varying correlation between microfinancial variables in Nigeria. Those variables are variables I've mentioned earlier. And the objective, there are three objectives we want to look at here. to model the time-varying volatility, spillovers, and conditional correlations. Then two, to test for asymmetric effects in correlation dynamics. And then thirdly, to identify the optimal model for forecasting and risk assessments. The methodology, we look at the monthly data from 2003 to 2004, that's about 21 years. And then the return series has its own model here for computing the return series. Can you go to the next this thing? The methodology is continual. We don't need to dwell here. Let's look, go forward, go further. Go to the next one. The next slide, please. The next slide. Then, at this point, the summary of this methodology is that we're going to look at the distribution for GAC. We employ the normal and students T as error distribution, and then distributions for the multivariate GAC, for multivariate normal students T and Laplace, and the software used is the R of this particular version 4.4.2. Then our findings here. When we use the return data, the return series, it gives us the exchange rate. You can see from the scatter diagram there, it is non-normal. From the oil price, you can also see that it is also non-normal, and invariably all of them, the stock exchange and the inflation are also non-normal using the return series. Please go further. And then we plot the histogram. The histogram here, if you look at also, the symmetry, it is asymmetric at the end of the day because it is skewed. If you look at this one, it's skewed. If you look at that one, it's skewed to the left. And this one is also skewed to the right, showing that they are also non-normal. Can we go to the normal one? Next slide, please. So now, if you look at table 1 here, the comparison between the symmetric and the asymmetric of these particular orders of GAC. We have, if you look at our AIC, the smallest AIC and the smallest BIC is what we are going to pick. If you look at the IIC for symmetric, DCC GAC with multivariate students distribution is giving us 23.68. And then for the BIC, it's also giving us 23.66. However, if you still look at the asymmetric of the DCC GAC with multivariate student distribution, it's giving us 23.69, and that of BIC is giving us 24.04. And if you look at closely, the difference between the symmetric and the asymmetric is very, very minimal. It's negligible. 23.68, 23.69. The difference is about 0.01. And the same thing here, making us, what this means is that the previous researchers were using symmetric, and we introduced asymmetric, and it's giving us something close to what they have been doing. Can we go to the next slide, please?
The presentation currently going on.
Next slide.
And participants will come out for their lunch.
And then if you look at table 2, we also look at the conditional correlation matrix. The conditional correlation matrix, if you look at the stock exchange against the oil price, that is the one that gives us a significant effect here, showing that the strongest model to use for this is the stock exchange rate and that of oil price. And it has been explained under the table. No, go for that. Then the symmetrical, the table 3 is also giving us the symmetric and the asymmetric dynamic conditional correlation parameter. The parameters are the alpha, the beta, and the gamma, and then the V. The alpha is the impact of past stock persistence, past stock. Then the beta is the persistency, while the gamma is the asymmetry, and the V here is the joint shape. And if you look at them, and the p-value is 0.0 less than 0.05, which means that it is still not significant. Can we move further, please? Next slide, please. Then we are going to conclude here. Conclusion. The parsimonious symmetric DCC model with a student T distribution is sufficient for capturing the dynamics of Nigerians' micro-financial variable. Correlations are dynamic but symmetric. Implications. 1. For investors. Is it me? For investors, diversification benefits are stable, but modest oil price and stock exchange index move together, offering limited hedging. Secondly, for policymakers, inflation management can be somewhat independent of financial market policy. Stabilizing the oil sector remains crucial for overall financial stability. Then our future research, we're going to look at this because what we have gotten introducing the asymmetric approach is not far different from what the previous researchers have been doing. But the difference is that previous researcher has been using 3 variables. In this case, we use 4 variables. We introduce inflation into it. Previously, no inflation. They've been using oil price, then the exchange rate, and then the, what do we call it? The sector, the oil sector, sorry. So the future research will incorporate global factors or regime switching models to account for residual cross correlation. We are still on this research and we should work for it. We're going to work further to get more, findings. Thank you very much for listening.
Thank you very much. Let's give a round of applause.
Thank you. Can I take small of your water?
We were told that after this session, go for lunch break. Please, observation questions. Let's take our numbers. Observation question. Okay, number 1. Who is number 2? Who is number 2? Okay. Brother number 2. Okay. Yes. Number 2. Okay. Mr. Abdullah, 2. Sorry, 2. Thank you. So let's start with you, sir.
Thank you very much. Thank you very much for the presenter. Definitely, this one and the previous one, they are alike in terms of the statistical tests. Definitely, so many questions were raised. In the decision making, what kind of statistical method, statistical test will use? So definitely here, people are asking whether you are using a null hypothesis or alternative hypothesis. So in decision making, this is why you can assume the null hypothesis is the assumption whereby you are determined to reject the assumption. Then the alternative, otherwise you will accept it. So definitely in the assumption here, we are actually to say that symmetric dynamic correlation is better, then the conditional asymmetric is not better. So definitely you have to what? You have two arguments. Yes, you have two arguments whereby you reject, then they accept the other one here. So definitely in that case, for his presentation, there is need to present the formula. That means the model statistical tools like student T distribution in their own formula. If there is computation in the computer, definitely one may design a program to actually compute it. Then the Laplace distribution. Also, we want to see it placed here so that to actually be able to design a program so that to run it on a computer. So thank you very much. It is very good actually presentation. Thank you very much. Yes, wait, okay.
Bring your mic.
Okay, he wants to.
Please, can I just respond to this?
No, just a minute, sir. Just.
Okay.
Yeah, please, I want to say as statisticians, you don't accept alternative. You either reject the null or accept the null. You don't accept alternative, please, as statisticians. It's only null alternative. Are you with me? You only use alternative alternative hypothesis to accept or reject the null. You don't accept alternative hypothesis. Please, we are statisticians, please, because. Okay, yes, good. I heard you mentioning accepting alternative, please. Thank you.
I don't know basic statistics, you know what they call type 1 error. Basic statistics, you know what they call type 1 error. That one is type 1 error. So number 2. Number 2. No, number 2. Oh, Dr. Mrs. Sorry.
You're welcome, sir. Sir, you made mention of the variables that in the asymmetric you add inflation. So I want you to tell us other variables that was used previously, the 3 variables with the additional ones.
Let me please start from the last question.
Okay.
Yeah, the other variables, the variables that have been using before, we also use it, but with an introduction of the inflation. Other variables being used before that are oil prices, exchange rate, stock market performance. We introduce inflation rates and then employ the asymmetric GAC model. Okay, to respond to the first comment, it's more or less a comment. Yes, it is true that the null hypothesis, which is our research hypothesis, is set with the intention to reject it. That's what he's trying to say. But this is, PowerPoint presentations. We don't expect to bring details of our work into this place. The details are there in the work. And if you want it, I will send one to you.
It's okay.
Okay, all right.
Before we let you go, no, I have a general observation. I mentioned it, I wrote it down to mention it a number of times, but I've not mentioned it. You know, one of the things I wrote down was that table title. When you have a table 1, the table title should be explicit enough to bring out the meaning of what the table is all about.
Let's put it down.
So your table title was just a model comparison 3.1. So that it was too brief. So your model title, most of you have that challenge. I wrote it down. We don't say it. So please, model title and your table titles are very important. They will be so explicit, no matter how brief it may be or long it may be. You should be concise anyway to reflect exactly what is in the table and what you are doing. Then I will say that to Dr. Mrs. asked a question. That question I also have it to ask. You said you introduced one extra variable, which is inflation. Myself and Professor Ejoban ask ourselves, what is the difference between exchange rates, present exchange rate, and inflation? Because what influences exchange rate is already inflation. So what is the difference between the two? Both of us quoted ourselves. Now I'm asking you. You may not need to answer, but we know that if you want to answer, you can answer anyway.
And of course, we should all know that exchange rate is different from inflation. Inflation is the effect on all the variables, the economic variables. The economic variables, not on only exchange rates.
Present exchange rates. What are the factors that are responsible for present exchange rates?
Well, if you look at it from economic point of view, the present exchange rate has so many factors. And factors that are not even in our book, that we know physically, it's included, that have never been discussed. With experience practically.
Language from one of our presenters this afternoon. Correlation between inflation and exchange rates is positive. So the exchange rate is a product of inflation. So when taking an inflation as a factor, and the exchange rate is already determined by inflation rates. Exchange of last year, this year, even previous weeks are never the same. It fluctuates. And most times in Nigeria, it doesn't come down.
And that's what I'm saying, that some of these factors.
Our fear is a problem of multipolarity. That was our fear.
And your equations, alpha 0, beta 0 will no longer come into place.
Well, we'll look at that.
Okay, thank you very much. Let's give a round of applause. I think we'll be instructed to go for the lunch break. Immediately after the lunch break, continue the session here again. Please, I implore us to eat quietly and come back. Thank you, and see you soon. Sorry, sir. So when we come back, we start with you. We get away with the chop now. We don't go that side. Yeah? Okay, wait. I didn't drink water. I'm not right for you. See some women, they've still not come.
No, exchange isn't always. There's other factors that can influence.
Is distribution pattern, market factors, demand and supply. They are part of inflation. When there is too many demand, price will come into play. But if there is no demand, the price also come down. Then the market force also include the supply, price and supply. Like when you supply now, we have many sources of bringing crude oil to Nigeria. How many sources of bringing crude oil into Nigeria? How many sources of bringing rice to Nigeria now? So the price are also affected.
My senior colleagues, you're welcome. We'll continue from where my colleague Prof there stopped. So the first on the list there is Kelechi Elachi.
Okay, I've given it to
Okay.
Isaiah.
Okay, please, you have 10 to 15 minutes. Thereafter, as usual, we will wait for observations and questioning. Hello, Mike, please, can we?
Okay.
Good afternoon, Prof. Good afternoon, Prof.
Please, can you
Hello.
the slide?
Good afternoon, all. Good afternoon, my professors and fellow scholars. I'm here to present on the research fusing modeling on malaria disease dynamics. My name is Ewere Kelechi Precious from University of Port Harcourt. And if you look at the slide, okay, fusing modeling on malaria disease dynamics. Now, if we go to the next slide, this is the abstract of the work. Has to do with machine learning has led to innovations through artificial intelligence and computational systems. Now we are looking, this research work is looking how we can apply the theories on fusing modeling to compartmental disease modeling of infectious diseases. Next slide, please. We find out that almost all data suffer from some kind of uncertainties or biasness or vagueness. And we know that machine learning also models these methods to model such uncertainties in order to bring out what's the hidden information on it. So machine learning as well experience inaccuracies from data that suffer from uncertainties, biasness as well. So fusing modeling is now a technique on how to solve this problem that arises in uncertainties, in biasness, in vagueness. So fusing modeling applies intelligent methodology using artificial intelligence, using semantic rules, qualitative rules, and natural language in order to solve the vagueness or unbiasedness that are found in machine learning techniques and so on. Now, the next slide. The previous. Now, when we talk about fusing, what are we talking about? Something that is not precise, unclear, vague, biased. Fusing is not clear. So fusing set theory as a basic or the fundamental for fusing modeling is a mathematical way to represent such vagueness or uncertainty by assigning what they call membership values to an element or entity within a unit interval 0 and 1. Next slide. When we talk about membership assigning quantities, next slide. Okay, the next one, before I start to explain what we mean by membership function, we look at the literature review, we see that several works on fusing modeling has been done, and they have been incorporated into different applications like fusing machine learning fuzzy deductive processes, fuzzy system control, and so on. There are so many research works that have done that. And they have also applied fuzzy modeling into modeling of infectious diseases using the SIS model, susceptible, infectious, and susceptible again, and other models. Next slide. Next one. Now, for us to have an idea what we talk about fuzzy modeling, we come back to the basics, the fundamentals, the fuzzy set. When we talk about fuzzy set is on a universal domain, is defined by a membership function, mu of A of X. That membership function, what it does is to assign partial values, to those elements for them to belong to that set. It's just, for example, if we have a set, let's say an element in a particular set, if the membership value is 1, that means that element completely belongs to that set. If it's 0, it is not a member of that set. But what fuzzy modeling does, what if there is a partial relationship? Maybe that element has a partial relationship to that set, and it does not also have a partial relationship to that set. You see that it is vague. We cannot determine. That is where the theory of fuzzy set comes in. It allows for partial membership of an element to be on a set by assigning membership values between the intervals 0 and 1. Next slide, please. Now, when we talk about membership function, what is a membership function? A membership function is a function that assigns elements in a fuzzy set within the unit intervals 0 and 1, meaning that an element can have a partial member having values like 0.1, 0.6, 0.7 up to 1. Now we can apply it on a discrete scale and also on a continuous scale. Next slide. Next slide. Okay, this is an example. No, go to the table. Next slide. No, it's not this one. This is not the slide. Go forward. This is not the exact slide. Okay, just go back. Stop here. This is the application. But let me explain the table of the membership values. What that table does is the table of possibilities of each element. You know, as the value increases from 0 to 1, so does the membership. You know, at the extreme, where you have 0 and 1, there is high possibility that an element belongs to a set or not. At the extreme, 0 and 1. In between, which is about 0.5, is a threshold between I'm not a member, I'm a member. That is what that fuzzy likely scale is talking about. It's just like you say something is absolutely sure, strongly, you are coming down fairly, likely, not likely. That is the scale. We use this scale to assign membership of any element to a particular set. Now, this is the whole concept of fuzzy modeling from the basic fuzzy set. Now, what is the application? Go back to, now let's go forward to the application. Fuzzy modeling is now applied on infectious diseases, on compartmental modeling. What we mean the SEI, that is susceptible, exposed, infectious, and recovered human population, and the susceptible, exposed, and infected mosquito population. So we are now going to apply the theories on fuzzy set on this model. Now let's go to the next slide. Next one. Next one. This is not the slide. There's supposed to be a diagram.
There was a piece of a diagram, but no diagram on it.
It will not be this slide.
No, this slide. It won't be this PowerPoint. diagram. Okay. How many purple is there? Is it one or two?
There are two different ones, but this one, check. It's supposed to be this. Well, let me bring my flash.
I think that would be better. Just hold on, if you see.
Sorry, it's in my flash, except for green my flash. You would have brought the one now that has the...
Fuse is only one now.
Let me bring my flash. Let me give them. Okay.
Just go and tell her what you have done. Tell her
Okay. 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 Now in this model, it has 7 differential equations. 4 for the human population part and the other 3 for the mosquito part. But for this purpose of this study, we'll only concentrate on the human population part. Now in the diagram, it has, for this part, it has 4 compartments for the human population. That is, individuals of the population progress from one compartment to the other. At the initial stage, when there is an outbreak of an infectious disease, the human population is susceptible to that disease. One can progress from that susceptible compartment to an exposed compartment due through contact. Maybe that person has been bitten by mosquito, the person progressed to the exposed compartment. Now inside the exposed compartment, that person will either be safe from that infection, malaria infection, maybe through natural immunity or through vaccine, or the person can as well become infectious. That is when the person becomes sick. And if the person is sick, the person now progresses from that exposed compartment to an infectious compartment. At that point, the person, yes, this is the model. This is the model I'm talking about. The person progresses to the infectious compartment. Now, if the person recovers, the person progresses to the recovery compartment. Now, this other one is for the malaria. If you notice, there is a relationship between humans in an infected compartment with mosquito that is susceptible. And so you know that a mosquito that is not infected, if it comes in contact with an infected human and beats that human, automatically it will be infected with the mosquito. The same thing goes here. The infected mosquito makes this human population in this first compartment to be susceptible to the malaria infection. So if these humans here are being bitten by this mosquito, you see they progress to the exposed compartment. That is the diagram. Now for the purpose of this study, we use set of secondary data gotten from World Malaria Report to show practical example of what we are talking about. Let's move to the next slide. This is the set of 7 equations. The next one. Now this is the FUSI model, the FUSI scale. It's a scale. This is what we see here is 0 plus. You know, when you do malaria malaria test, the result you see plus, +1, +2, +3, +4. Now you see the membership values being assigned. When it's +1, 0.1. By the time it gets to +2, this is 0.4, just like that. By the time it's 4+, it's 1. That means automatically that person is sick of malaria automatically. Now let's progress. Now when we talk about FUSI modeling, spreading infectious disease, there's one thing we have to talk about: the reproduction number, RO. What is RO? RO has to do with the average number of persons one infected person can spread the disease to. I may be infected and I spread it to 3 persons. That 3 persons can also spread it to another 3 persons, which is 9. So that is what RO does. Now let's go on. Now we'll talk about the equilibrium points, disease-free equilibrium, and the endemic-free equilibrium. Now when we talk about disease-free equilibrium, we say that if the RO is 1, then it's less than 1, then we say that we have a disease-free equilibrium. And it is unstable when RO is greater than 1, when this V here represents the amount of parasites in a milliliter of blood sample. Now, when you take your blood sample, the sick of malaria depends on the amount of the parasite in that blood. That is where we have the physics scale. If the parasite is above 4, you have 1 plus. If it's above 40, you have 2 plus. If it's above 400, you have 3 plus. If it's above 4,000, you have 4 plus. That is where we link it. Now, in our analysis, let's go further. Now, this is our analysis. In our analysis, we find out that if this is not clear, this is time. We model them at time 0 at the initial incidence where we have an outbreak. Time 1, 2, 3, 4. This is susceptible group, infected, exposed, and recover. If you notice that as the susceptible group decreases, so does the infected, exposed increases. And if you notice from the figures, it's not clear, we find out that there is a gradual decrease in the number of infected individuals. This may be due to the nature of the disease. And there is a gradual increase in the number of recovered persons. Next slide. The next slide shows the trend. The susceptible group, which is the blue line, and the number of exposed, the amber line. Then you see the number of infected individuals. It decreased gradually. There's a slow decrease, perhaps due to the nature of the disease. And this green line shows a slight increase in recovery. Now let's go to the next one. Now we calculated our RO. And our RO is 0.0049, which is less than 1. That means an epidemic is less likely to occur. Illness from malaria does not cause an epidemic from our analysis. Now, if you notice that our V here is greater than 4, that means fusy disease-free equilibrium cannot be attained. What that means is that malaria is present all year round in Nigeria. Why do we say the V is greater than 4? We know that for a population to have disease-free equilibrium, that means the number of infected persons must be 0. Whereas at the initial outbreak, we know that we have about 680 something persons already infected at the initial outbreak. So that means we cannot have disease-free equilibrium. So in summary, the summary shows that the concept of fuzzy sets and fuzzy theory can be applied to studies that lack precise knowledge or information about a course of study. When we do this, we find out that it can be applied to machine learning techniques which produce more robust options to problem with uncertainty, meaning that information actually is not entirely lost. So Fuji modeling is like an interpolation between vague or unprecise information. It's like an interpolation, bringing out these values to real life, and it's being applied. So malaria disease, we know, is recognized as a health risk that is persistent. So when we apply theories like physics modeling into and compartmental modeling, we'll be able to know how well we can curb the spread of an infectious disease. Thank you.
Yeah, as the tradition demands, please, questions and observations. Okay. Please, any question and observations, please. Your contributions, please. Any? Okay, thank you very much. Well, for me, I think you have made a valuable attempt in using fuzzy modeling on malaria. However, I have some challenges in your result. Your result, can you display that again, please? It says that RO is less than one, which is 0.0049 or thereabout, showing that there's no epidemic, right? But you and I know that truly malaria is endemic in Nigeria. So how do we reconcile this with the result, with the present event? Based on his result.
The data I use.
Yes.
I use World Malaria Report data of 2003. So based on their data, I used to analyze
the data.
To find out that the ROO was less than 1, which means that an epidemic is less likely to occur. If there is a maybe variation in the data in the future, then we can have an epidemic. But from our analysis, based on this our analysis, so an epidemic is less likely to occur.
Okay.
Based on this analysis.
Data, okay. Thank you very much.
Only 1 year. Yes. Only 1 year. Yes, for Nigeria, World Malaria Report for 1 year. Yes, for 1 year.
Sorry.
This, we are in 2025 and using a data of 2003 in drawing a conclusion. 2023. Is it 2023? I was thinking it's 2003. I would have said. You said 2003. That was what you said. Otherwise, better. If it's 2023, we can pick on that. But if it's 2003, it's terrible. Thank you.
Thank you very much. So please, can we? Okay.
I think that just using 1 year data is not fantastic enough. So before you can conclude for something like this to be published on our journal, it's supposed to be maybe about 10 years. About.
Yes.
So you can summarize the daily data now. You can summarize them, put them in such way that so that we don't mislead the public. Thank you.
Thank you very much. Thank you. Okay. Please, can we clap for him? Yeah. Next, I don't know if this guy is here. Best are okay. Is he around? I don't know. There's no other person again.
The decision, Dr. Atoy said that those whose papers were not captured were not going to be presented.
Yeah, these ones were captured because they were all sent to me.
Yes, but they are not here. We are now. They should register their names so that we get the capture of their detail here. They are not only this person.
Okay. I don't know.
And
so no other person.
It appears none. And Dr. Atoy said that when he asked him, he said he forwarded his paper to a wrong email. And he's here.
But my how do you forward the paper to the mail? Okay, I don't have it yet. I don't have it yet because what I have. So I don't know. No other person is around here. So please, while we are, I think let's just wait for the other 4 candidates.
4 of them, not
yeah, 4. They are supposed to 5. Only 1 has presented. The other 4 are not here. I don't know. Go on.
He says behind. Directly behind.
We still have 4 of them, but we're waiting to see if they can. Okay, we don't know where they are.
you, sir. No, we are not done, but we can't find the other 4. We've been expecting the other 4 candidates. Yeah, it's like from the look of things, it's like they're not coming. My brother, I don't know what to do again because the truth is that it's like those guys are not even around at all. I have to call it a day now. Yeah, maybe we'll go and join them then. Because let's go there. Some of these guys are not serious. And this guy is not around though. Chairman, how far now? Well done, my brother. Our people don't agree come again to complete their presentation. I don't know. From the look of things, I don't know whether the other 4 will still come. Sorry.